Hey guys, it's Miss Miklos, and today we are really getting straight into some calculus. And we're going to be talking about what we call the tangent line problem, and we're going to talk about derivatives. And you guys may have heard the term derivative before. Normally we think of calculus as being about derivatives and integrals. Those are kind of the two major things. And today we're specifically talking about derivatives. Before we get into derivatives, though, we're going to talk about the tangent line problem. And the slope of a tangent line is really going to be our goal today. And I know normally when I hear slope of a line, I think of a linear equation. So something we can get in slope-intercept form. It's the same over the entire function, and it's easy for us to find. However, we know that rates often change. Okay, if you think about like when you are driving, when you're driving to school, you're not always going 40 miles an hour. Okay, there could be times you're going 0 miles an hour because you're stopped at a stoplight. There could be times you're going 65 because that's the speed limit on the freeway. Okay, and depending on where you are, your rate of change varies. And that's really what we see in a lot of real life functions. So in order to determine the rate at which a graph rises or falls at a single point, we can find the slope of the tangent line at that specific point. In simple terms, the tangent line to the graph of a function f at point P is the line that best approximates the slope of the graph at that point. Okay, so here's some examples. I'm going to zoom in a little bit here. Okay, we can see this function is changing. Okay, it would have a slope that's closer to 0, and then the slope increases, and then it gets back to being closer to 0 again. But if I'm just focusing at point P, this would be a tangent line, okay, because it's only touching this graph in one spot. Now, if this tangent line continued, it would intersect down here again, but that's okay. We're really just looking at in this specific area. Okay, our next one. Okay, we have like an exponential decay, and we notice it's decreasing quite rapidly and then kind of evens out. So at this point, this line would represent the tangent line. So if we could find the slope of this line, that would give us the slope at that point. Our last one here, we have a parabola, and a parabola has a variety of slopes. We have some negative slopes, some positive slopes, and at this point, this is a horizontal line, so that particular slope would be 0. In geometry, we learned that a line is tangent to a circle when the line intersects the circle at only one point. Tangent lines to non-circular graphs, however, can intersect the graph at more than one point. And that's what I talked about in this graph up here. So the first examples that we're going to go through, I'll be honest, are super easy because a tangent line is already given to us. When it gets more difficult is when we do not know what the tangent line is and we need to try and figure that out. So number 1, it says approximate the slope of the function f of x equals x squared at the point 1, 1 using the given graph. So I just want to remind us, first of all, remember we use m to represent slope. You guys probably remember that slope is rise over run. We also see it as delta y over delta x, which means the change in y over the change in x. We also see y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Those are all things that we use quite a bit. There's more that correspond with slope, but I think if we know those things, we're in good shape. So we're trying to find the slope here at 1, 1. Our function is f of x equals x squared, so we can see that there is also a point that is at 2, 3. And they've actually done a lot of work here for us already because they're showing us that the rise is 2 and the run is 1. So in this case, our slope would be rise over run, which is 2. And I should say 2 equals our m. And that's really all we would need to do. So you guys can see if this is given to us, life is easy. Now, this seems like an appropriate answer because it is a positive slope. It's rising from left to right there. So number 2 gives us another graph, and it says use this graph to approximate the slope of the curve at the point x, y. So they have given us a tangent line, and we don't know what this equation is, but that's okay Because if I zoom in, I can clearly see a few points. I'm going to go ahead and use this point, which is 0, 2, and I'm also going to use this point, which is 2, 0. Now, I want to point out that since this is a linear equation, I could pick any point on that line, and it would give me the same slope. I just think the intercepts are easy. Okay, so to actually find our slope here, I'm going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to do 2 minus 0 over 0 minus 2, which gives me a slope of -1. And if we look at this, that would be an accurate answer because it is falling from left to right. So at this point, you guys should be feeling good. It's like living the glory days from Algebra 1. But unfortunately, those glory days are over now, because now we need to find the slope of a graph when the tangent line is not given to me. So I just want to kind of talk us through this, okay? This is what we call finding the slope of a graph using the limit process. Yes, limits are important. That's why we've spent time learning them. But what we have here, we have just a function, okay, and we have two different ordered pairs on the function. This first ordered pair is x, f of x, because we know f of x represents y. Now, we don't know what point or what the tangent line is, but we can figure out what the point of tangency is, because often they will tell us, like, find the slope at x equals 5, or find the slope at x equals -2. That's the point of tangency, so that kind of represents this point. Now, all this is saying is that I'm moving over a certain amount, so we're calling that x plus h. Our y value then is whatever the value of the function is at x plus h, so it means that I'm substituting that in. And so what we end up getting here, this distance is h, because x plus h minus x gives us h. And this really represents the change in x. Now over here, what we're doing, we're taking our y values and we are subtracting them, so this is the change in y. So even though these values look a lot more complicated, all it's doing is finding the rise over the run. Now ideally, okay, and it kind of talks about that right here, like the graph of f at x, f of x is equal to the slope of its tangent line at x, f of x. Okay, that's really what it's talking about. But ideally, I want to make this distance 0, because if I don't have a distance here, that means that this line is really the tangent line. So as these get closer and closer to each other, it gets more accurate. So the equation that we need to know here, the slope is equal to the limit of f of x plus h minus f of x over h as h approaches 0. And we call this our difference quotient. This is something I would expect that you guys have memorized and that you know how to use it. Okay, so number 3 here says, use the limit process to find the slope of the graph of f of x equals x squared at the point -2, 4. And I just want to start here, not by drawing a random line, but I want to just quickly kind of sketch what this should look like. Okay, so I know that this is kind of like what my parabola would look like. A little rough there by me, but that's okay. And they're saying we want to find the slope at this point. So even though my tangent line is not perfect by any means, I can kind of give myself a little picture of what that would look like. And some things that I know right away, it should be a negative slope. Okay, so we're finding the slope of the graph, f of x equals x squared, at the point -2, 4. So I just want to point here that -2 is our x value, and 4 is the value of the function at -2. So if I'm going through this, Okay, I'm going to write that the slope is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So looking at this, okay, this is where we're always going to start. And what makes this problem unique is that it's not asking us, what's the formula for slope for everything? We only care what is the slope at this point. So I actually know an x value. So I'm going to go ahead and say m equals the limit of f of -2 plus h minus f of -2 over h as h approaches 0. Okay, so when they give us a specific x value, I can substitute that in, and it's just going to save me a little bit of time. Okay, so I need to go ahead and figure out these two values. So I'm going to start, and I personally like to do this off to the side. I'm going to do f of -2 plus h. And just to review what that means is that wherever there was an x, I'm replacing it with -2 plus h. So I have -2 plus h squared, which I need to FOIL, and I get 4 minus 4h plus h squared. So I'm going to go ahead and write that in here. So I have 4 minus 4h plus h squared. Now, I also need to find f of -2, and there's two ways we could do that. We could substitute -2 in for x. I know -2 squared is 4. Or we could have looked at the very beginning. They told us f of -2 is 4. Either way, though, I get that answer. So now I'm going to go ahead and simplify my numerator. And I notice that these 4's cancel each other out, so I have -4h plus h squared. Now, if I substituted 0 in right now, I would get 0 over 0, which is indeterminate form. So I need to recall some methods that we've learned, and I'm thinking that this is something that we can actually factor. So I'm going to factor out an h, and I'm left with -4 plus h over h. So these h's cancel out, and at this point I can use direct substitution. So I get that our slope is -4. And if we look back at our original problem, even though this line is not accurate, I think that -4 would be an appropriate slope for a line like that. I also want to point out our notation here. This is super important. Okay, so number 4, this time it says find the slope of f of x equals -2x minus 4. Now, if we're using common sense, this is a linear equation. My slope should be -2. But let's go ahead and use this process just to verify that. This time, I just want to point out that they're not telling us find the slope at a specific point. They're just saying find the slope of this line. So that just means I'm going to do things slightly differently here. So I'm going to write out finding the limit as h approaches 0 of f of x plus h minus f of x over h. And I'm going to start off here by finding what is f of x plus h. So this time, it means that wherever there was an x, I need to replace it with x plus h. So I get -2 times x plus h minus 4. So -2x minus 2h minus 4. So I'm going to go ahead and write out -2x minus 2h minus 4. F of x, we know, is -2x minus 4. That's function is given to us, so I'm going to go ahead and put that in. And now I'm going to have to go ahead and distribute. So I have -2x minus 2h minus 4 plus 2x plus 4 over h. And I notice that these x's cancel each other out. So I have the limit as h approaches 0 of negative 2x h over h. When I cancel out these h's, I am left with negative 2 being my slope. And what's kind of weird here is I can't really substitute negative 2, I really can't substitute 0 in because I don't have any more h's left. So I just know that our answer is negative 2. And that's what we said our slope should have been based on the fact that that is a linear equation. Okay, so I just want to point out here the difference between finding the ways the difference quotients were set up. Okay, in our first one, we put in a specific x value and that found the slope at a specific point. The second one, we found the formula for the slope. If they're asking us only to find the slope at one point, this is the way that we should use. If they ask us for a formula, or we will see that there are problems that ask us to find like 3 slopes at 3 different points, I would find the formula and then just be able to work backwards and substitute in. So looking at number 5, it tells us find a formula for the slope of the graph of f of x equals x squared plus 1. So this is one of those problems that I want to find a formula for the entire function. So I'm going to go ahead and say that we're finding the slope that is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So off to the side, I'm going to figure out, okay, in this case, what is f of x plus h? And that would be x plus h squared plus 1. So if I FOIL this, I get x squared plus 2xh plus h squared plus 1. So I'm going to go ahead and write that in. Okay, so I have the limit as h approaches 0 of this over h minus f of x is x squared plus 1. So when I go ahead and distribute, I have x squared plus 2xh plus h squared plus 1 minus x squared minus 1 over h. So if we look, our x squareds cancel and our 1's cancel. Now I'm going to kind of skip a step here because I notice in the numerator I can factor an h out and I'm left with 2x plus h. And I got that just by looking at what was left and I had an h in both of those terms. So these h's then can be canceled out and I can use direct substitution and put in 2x plus 0. So I get that our slope is equal to 2x. And the reason why this is really helpful for us to know is because if we look at part B, I don't need to go back and use that entire limit process. I can just use this particular ordered pair and substitute it in. So we know the slope is 2x, so my slope would be 2 times negative 1. So our slope is negative 2. And if you guys had done this whole process with this ordered pair, this is the answer we would get. For C, it says find the slope at 2, 5. So I'm going to say m equals 2x. So the slope is 2 times 2. So our slope this time is 4. And if we take a look at this, okay, it would make sense that at negative 1, 2, we had a negative slope. At 2, 5, we have a positive slope. So the final thing that we're talking about here is the derivative of a function. So in example 5, we started with f of x equals x squared plus 1 and used the limit process to derive another function, m equals 2x. This derived function we also call the derivative of f at x, and it is denoted by this notation, which we read as f prime of x. So if it's asking us to find the slope of the tangent line, it is exactly the same thing as asking us to find the asking us to find the derivative. The only new thing, instead of m, we are using this notation, f prime of x. So number 6 says, find the derivative of f of x equals 3x squared minus 2x. So I'm going to say f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. So off to the side here, I'm going to figure out, okay, what is f of x plus h? So I would get 3 times x plus h squared minus 2 times x plus h. So I have 3 times x squared plus 2xh plus h squared minus 2x minus h. So I have 3x squared plus 6xh plus 3h squared minus 2x minus h. So we have a lot going on there, but that's all going to go ahead and go into this equation. Okay, so we had 3x squared plus 6xh plus 3h squared minus 2x minus 2h. And then I need to subtract f of x. And we know in this case f of x is 3x squared minus 2x. And this is all over h. So I have f prime of x equals the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x over h. So things that cancel out, my x squareds cancel out, my 2x's cancel out. I notice that these terms that I have left in my numerator all have a GCF of h. So I can take that out and I'm left with 6x plus 3h minus 2h. Minus 2 over h. So I took an h out of all three of these terms. We can go ahead then and cancel out these h's. And now I need to substitute in a 0 wherever we have an h. So I get 6x plus 3 times 0 minus 2. So my answer is going to be f prime of x equals 6x minus 2. So notice we did the exact same thing here. We just used slightly different vocabulary. Okay, for number 7, it says find the derivative of f of x equals 3. And I wanted to go through this one because this is kind of a weird one. So I have the limit, or I should actually start by saying f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. And if we're going through this one, okay, some weird stuff actually starts to happen. Because if I am substituting x plus h into this function, notice there's no x. So my answer is just 3. And the reason why, this is just a horizontal line of y equals 3. So at every single x value, the output is 3. So I get 3 minus 3 over h, which is 0 over h, which this kind of gets us in some weird territory. And we're going to say it's 0. And if we think about it, the derivative, this is a horizontal line, which has a slope of 0. So it would make sense that f prime of x here is equal to 0. So kind of just a weird one because that's a horizontal line, but it's reminding us that we should always be aware of the original function and what we're doing. So now we've gone through all of our examples. I'm actually going to show us a quick shortcut that we can use to check our answers. We can't always use it to find our answers, but we can always use it to check our answers. Okay, so as I said, I want to show you guys a little shortcut, and this is something that we can use to check our answers, or if it's multiple choice, and it's something that we call the power rule. So just to recap here, we can use it if it's multiple choice or just to check. When we really cannot use it is when it uses the term the limit process. So the way that the power rule works, let's say our function f of x equals x to the nth power. If we're finding the first derivative, so f prime of x, what we're going to do, we're going to take this exponent and move it out in front to be the coefficient. And then we're going to drop that exponent by 1. So it becomes n times x to the n minus 1 power. And if we look through that, it actually makes a lot of the problems that we did way easier than they were by doing the long way. So if we have something like f of x equals 3x squared minus 2x. Okay, if I was using the power rule, so f prime of x, I'm going to go ahead and move this 2 out in front. So I have 2 times 3x, and my exponent then would become 2 minus 1. In my second term, that is like to the first power. So I would go ahead and I would do minus 1 times 2x to the 1 minus 1 power. So if I'm going through this then, I would say f prime of x equals 6x minus 2. And the way that we get this, okay, I know x to the 0 power is just 1. So negative 1 times 2 times 1 just becomes negative 2. So if we look, we're just bringing the exponent out in front and multiplying, dropping this by 1. Let's do another example. What if we had something like f of x equals 5x to the 4th minus 3x squared plus 8? Okay, so I'm just going to go ahead and go straight into this. So f prime of x equals 4 times 5 is 20 x cubed, because I'm dropping it down 1. 2 times negative 3 is negative 6, and then x to the first. Now, this 8 is kind of strange. That's like we have x to the 0 power. So if I bring this 0 out in front, 0 times 8 is 0, so I don't have anything. So this would be our final answer. Now, I know sometimes we learn something like this, and it's like, seriously, I need to use this long, complicated way. And yes, you do, because knowing the limit process is extremely important in calculus. However, this is a good way to double check our work. So that's about it for the slope of a tangent line, which we know is exactly the same as finding the derivative.